Can you hear me? Excellent. Can you see my screen?
Yes.
Excellent. For whatever reason, Microsoft doesn't give me that option to actually see my own screen on it. So what I will do is I will go to the presentation itself and see if I can run it from there. To begin, let me first of all thank the organization. I understand that you have guests, speakers from time to time to let everybody know about the latest advances in technology. I would like to thank also the Government Blockchain Association. I believe Gerard is here also on the call. I saw him on the list. Thank you for giving many organizations from all over the world the opportunity to speak with government representatives and to show what the latest technical solutions and products are available out there for government use. A few words about myself. My background is in finance and accounting. I'm a CPA and about 25 years of working in large investment banks in risk management, general management, and C-level management capacities in several countries. Most recently, about 2.5 years ago, I joined a blockchain community called Everscale. Now, it is interesting with its own background. Everscale is a community built around a particular technology called Everscale Network, which has some unique characteristics. First of all, there was never an ICO. It did what is called a fair launch, which means that only participants in the process itself were spending their own money. There was no borrowing, there's no debt. Everscale is a meritocracy, which means that every single token ever issued is given for contribution. So we have a number of mechanisms such as contests where people can come, do their best, and then if they succeed, if they're better than others, then they get a significant reward. So meritocratic distribution is another interesting characteristic. Now, on the technical side, there are also a couple of noteworthy features. Number one, the architecture of Everscale network is very unique. It is what is called linearly scalable, which means that essentially you can have any number of smart contract executions per second you want, as long as you bring enough validators to the network. And that feature is a must if we are talking about mass adoption for blockchains in real life. So an ability to scale is critical for that. Some of the practical tests that we did over open internet, not in a lab, over open internet, the latency, which this parameter is called, we demonstrated is 50,000 smart contract executions per second. Very, very high number. Very few other networks are able to show that, if any. Most of the latency results demonstrated are from the lab, but the open internet presents additional challenges. So for mass adoption, you need to work with those numbers. In terms of the network finality, which is another critical characteristic of a blockchain, we have achieved close to under 2 seconds. And the goal we are striving to achieve now is actually a sub-second finality, which, as you understand, is critical for applications which are time sensitive, such as decentralized finance, for example, where a settlement of a transaction of a buy or sell a particular cryptocurrency must be settled immediately in order for this to be an efficient and effective mechanism. The third important characteristic of a network that allows for mass scalability is its cost. The unique architecture of Everscale allows you to decrease gas fees with the increase in volume of transactions. So at the moment, we have something under 10 US cents, which is close to 100 times less than, for example, Ethereum. So we are looking to further improve this parameter. We believe that the cost should be very, very low for using the blockchain as an important condition for mass use and mass adoption. Now, those characteristics of the network allow us to build some very interesting and important products for various use cases. I will start with, today I was hoping to present, time permitting of course, two of them, or at least one. Both are in the elections industry space. We developed two products, one for remote ballot marking and return, which slowly but surely finds its way in the US election space. The other one is called DeAudit, which is dedicated to what's happening at polling stations. So together we're hoping that both the remote mechanism and on-site mechanism will achieve a few important tasks that the elections industry in this country is seeking right now. So let me start with DeVote, which is a remote ballot marking and return system based on a mathematical wonder called Gross 16, among other things, which allows you to essentially prove that somebody voted without actually knowing how. That is applicable for a variety of types of use cases. We start with colleges, universities, and nonprofits. And I'm happy to report that Government Blockchain Association is one of our first clients. We actually conducted a pilot at the Blockchain and Infrastructure event GBA ran in May of this year in Washington, D.C. Conference participants were able to vote on the best NFT in the show of digital works of art, which took place in parallel to the main event. And to me, as far as I know, it is the first ever public use of Gross 16 technology in the blockchain-based voting. So we were very happy to pilot it there, and we have a number of customers right now looking forward to working with us to be able to use this otherwise known as zero-knowledge SNARKs technology. So the second group of potential clients are condominiums, co-ops, country clubs, and similar associations of people. Also, sports societies conduct numerous votes on an ongoing basis, and there is no technology currently available to address some of the critical issues that are being raised in the voting industry. Well, obviously, businesses are also important here. Corporations, like annual meetings, any decisions the company needs to make as it goes, limited liability companies, and DAOs. In fact, the voting mechanism and the consensus mechanism are critical parts of any DAO. And I know that at today's session, I was asked to talk about DAOs. So voting is a very, very important feature of any DAO, how it is conducted, what is the mechanism for consensus protocol. For example, we use the modified Byzantine fault-tolerant protocol and also the so-called soft majority voting principle, which allows for to address the voter apathy problem, which is well known and one of the issues that needs to be addressed. And then last but not the least, of course, we go to political elections, local level first, then state, and then eventually, hopefully, federal. Now, we heard a lot of presentations on decentralized voting in various groups, particularly a large systems integrator, EPAM, is running conferences and events from time to time on this issue. And the complaints that we heard from participants were, first of all, the lack of mass adoption at the moment, blockchain technology being very new is not yet a daily thing for most of the people. And we believe that that needs to be changed. The trust issue, of course, is at the forefront of attention in elections industry, where you want to remove any third party participants in the process, remove any need for trust. The need for extremely secure protection that can be achieved by using a certain type of cryptographic protection is available and is used in our products as well. We are cognizant of the need to separate the private versus public networks, while most of the customers in the private sector are happy with having permissioned private blockchain. In public space, there's more need for networks and for solutions that are public, and therefore they have their own unique characteristics and features that are important for the process. And as I mentioned, consensus protocol is one of the critical components of any solution. So what the Everscale community developed, and essentially the product was paid for by community funds. So people jointly got together and established some rewards for IT companies that came and participated in the contest to provide the best solutions. Now, the most important things here are the characteristics of any voting system that we believe has at least has some chance of being adopted in the society. Number one, it must be accessible, open to all of those who are eligible to vote. It must be very fast. It cannot allow for situations like we have frequently now when a voting window closes, but the polling station workers were still unable to count all of the bulletins submitted. That is an important problem today, which does not allow the country as a whole, for example, to have all of the results of its citizens' votes by the time on the election day, by midnight usually. There are still boxes unopened, waiting to be counted in many election commissions spaces where the local elections are run or federal elections are run. Now, we also believe that the system must be convenient and easy to use, for example, for senior citizens to be able to fully participate. My mother, for example, is 93 years old, and it is very difficult for her to actually physically go to a polling station and express her vote there. Now, this group previously talked a number of times about security issues, and of course we know that political elections are subject to a lot of threats from various threat actors, so we must demonstrate that basically the protection level, the security level of the system is adequate. But most important, the elections run by any system, we believe, must be indisputable. And that can be achieved by only an open source, open code system, which anyone can go and verify. And that also includes an ability of a voter to actually audit the system right from the device where he or she is using to vote. So all of those things were taken into account when we were working. Now, some of you, of course, are aware of an incredible high cost of running elections. Just during the 2020 cycle, we believe that the total cost of both congressional and presidential race was close to $15 billion. A system like ours can certainly reduce that cost by a significant factor, because again, as I said, the network itself allows for very low cost transactions. So we are hoping that one of the results of new technology being used in the space is the overall reduction of cost for its participants. Now, the main problem with remote voting today, as has been well highlighted by a number of authors, is that no existing remote ballot return system is open source, decentralized, and at the same time compliant with the legal requirement in the US of permanent separation of voter affidavit and voter ballot. So this severely limits today the use of mobile voting. So I think any technical solution must address this legal requirement. So what we were able to build is a remote ballot marking and return system, which is decentralized. It is 100% on-chain. It's using Gross 16 technology, which again removes that major issue of any administrator running elections today being able to see how somebody voted. Gross 16 allows you not to know. So it's very important to have something similar. The platform itself should be able to process all of 150 plus million registered voters in the US today. It is 100% compliant with the law, and as I said, it is open source and allows anyone to get a free software license. Essentially, the process is rather simple. First of all, the setup. The organizer collects a list of voters' public identities. Usually the elections committee would be the source of that. Then the voting window opens, voters submit their ballots publicly, and then the tally. The organizer tallies all of the received votes using the system. So the technology itself, for those of you who would like to take a closer look, can be found on GitHub under Neil Foundation. Neil Foundation is the winner of the contest that Everscale community ran. So it's published under Neil Foundation and then /vote saver protocol. So I would love for all of you, when available, when you have some time, to go in and take a look to see what the technology is about. Briefly, I will share the very fascinating story how this product came about. Some of you know that in 2020 there were several publications criticizing the use of blockchain in election systems. Our community believed that a response to those opinions should be given, and we ran first a contest to create best theoretical response. So in December 2020, we received close to 50 submissions, many from renowned PhDs and experts in the field, that laid out a theoretical roadmap for any solution to address those criticisms that were voiced. And then we ran a second contest based on the winning paper for actual practical implementation. So by the end of 2021, we finished coding of the backend, the engine itself, and then this year we started working on front end and decentralization. So as I said, in May of this year, we were able to do a first pilot in Washington, D.C., and we exchanged information about it with a number of renowned experts in the field, whom we're hoping to see as our allies in the space. Now, at the moment, there are a number of improvements that we must add to the system. User identification is one, which raises also a number of issues about security and decentralization. We also need to ensure that localization of nodes is possible. That is necessary, for example, for countrywide elections, if the law says that all the nodes or all the participants in the process must be US citizens and or located physically in the United States of America. So that's still a bit of a challenge for us, but we're actively working to resolve, and I believe by the end of this year, we probably will have both full end-to-end decentralized functionality and an ability to localize nodes, coupled with being able to address any number of transactions per second, which, as we understand, is critical for 150 million potential voters. So this year we are starting both commercial activity with private sector, and we continue to be free for any government or non-for-profit use. Now, why we are coming out with this product today? Basically, we have successfully completed the MVP stage. We achieved the end-to-end decentralized core functionality of the product, and we demonstrated the first pilot case. Now, work of the team behind DeVote was based on a number of positions by most authoritative organizations in the space, such as verified voting and other sources of fundamental requirements for voting on blockchain. With that, Joshua, I'd like to complete the first part of my speech and maybe open it to any questions about the remote product we have before maybe I say a few words about what we can do to help increase trust at polling stations themselves. Joshua?
Hey, thanks, Eugene. I didn't see any. I do have a question in chat from Sandy. So Sandy's asking if you'd be interested in loading these use cases into the Act-Iac National Use Case and Solutions Library.
Oh, that would be wonderful. I have no prior experience with that, and if somebody can help me, would be most excited to share any solutions to be listed in such places. So, of course, we'll be happy to do so. Please reach out to me directly through Joshua, and we'll do what we need.
Thanks, Eugene. I will. I'll actually reach out to you myself, and we can walk through that.
All right.
The next question is from Ryan Wald from GSA. Says he's curious where the boundaries are between the chain and identity and language localization. Said the last two are typically app concerns.
Well, it's a complicated issue. I don't know exactly what conflicts are seen here potentially. What we are trying to achieve is the compliance with the required safety and security measures, both with respect to the actual voting process and with respect to the voter identification mechanism and any lists of eligible voters that local election officials produce. So safety and security and inability of anyone to change the data in any way are achieved by moving the information both about voter eligibility and about bulletins themselves to blockchain. Same with the actual voter choices. So basically, you try to avoid any potential threats at the immutable level of a blockchain. I don't know if I'm answering your question. Maybe if you can rephrase it for me, I'll be happy to give more information. With respect to node localization, the simplest mechanism would be to introduce KYC process for any node operator. And this is something that I believe the society is comfortable with. In fact, billions, if not trillions of transactions are today sent over blockchain networks using a certain system of identification of participants, both in centralized and in decentralized space. And I believe that the mechanisms are available today to ensure that nodes are localized properly and that nobody from an outside country has access to the process or participates in any way. So again, if and when the requirement is to localize, that's an important feature that has to be addressed. Thank you.
Hey, thanks, Eugene. I think you briefly touched on this. We have another question, this one from David Chung, which is, what are the measures taken to ensure code security for data integrity?
Yes, that's a great question. And first and foremost, this is an open process. So everything, of course, with the anonymity of the voter guaranteed, and it is guaranteed by Gross 16 or zero knowledge snarks technology, which only appeared in implementation just over the past few years. It just didn't exist before. The theoretical papers by mathematicians were available for a few years already, but the practical implementation just came about. So this is very, very new. And this assures the voter anonymity. Now, everything else is fully transparent. So you, as an independent observer, you will be able to audit the whole process from beginning to the end to make sure that there are no violations of any kind. So the very nature of open source process where every participant can verify everything is the only possible answer to your question. Otherwise, you have to rely on some third-party specialists, you have to trust somebody still, and that's not a good approach. We believe that principle everybody verifies everything is the only one that allows you to really make elections, among other things, to make elections indisputable. This is our goal. We want to be able to demonstrate that the whole process is transparent from step one to last step, and anybody, should there be any violations, should be able to bring this to everyone's attention. Thank you.
So, David Chung, yes, David Chung has a follow-up, and then he's going to unmute, and then we're going to move over to Gerard, who's been patiently waiting.
Yep. Thank you. Sorry, Gerard, to hold you up there. No, thank you for the response. I'm just curious, right? So the average user who's going to be participating in the election, they're not going to take the time to go ahead and review the results from the beginning to the end, nor will they have the technical capabilities to review the code. Now, you did mention that, you know, another option would be having a trusted third party perform a security audit. You know, would that add value in actually doing that to you know, I guess gain more trust within the community, saying, hey, here's the results of a security audit. You know, we've put the code through subject to a bounty hunt, right? And are those type of like initiatives going to be put in play?
Well, they have to be. The real value of this technology will be seen and established by the society only after enough technical experts such as yourselves go in, take a look, and verify and produce their opinions publicly. So we would certainly welcome any organization that positions itself in that space to come and look. Providing additional assurance for users is very important. I certainly agree with you that the majority of people are not technically able to appreciate the product itself and understand how it works, nor there any need to, right? So what's under the hood is open and available for those who do want to come in and form an opinion and share an opinion with constituents, and we welcome everyone, as I said, to do so. So yes, there's a big role in the process by for experts who we believe collectively will form the perception in the society of the high reliability and security levels of any particular mechanism used in elections. So the answer is, of course, yes. Thank you.
So then at what point will the security experts be engaged? And I'm not asking for myself, right? I'm just asking for, you know, the betterment of the product here.
At what point you can get engaged?
No, at what point will the cybersecurity community be engaged to say, okay, guys, start looking at the code and hack at it to find any vulnerabilities?
That's a great question. We would love to have organizations that have such technical experts as its members would actually help on that. We already now, right? We can the code is there. It's open source. We can provide all the necessary links and answer any questions. Again, the job is in part on us to familiarize, first of all, the expert community with those solutions, experts such as yourselves on this call, and then provide whatever guidance or advice to those who want to take the code and implement it in any particular type of elections, again, locally or maybe for commercial use or for state level. So we are here. The code is available, so that process can start right now. In order to bring enough experts, of course, we need help with organizations such as GBA.
Absolutely.
Thank you.
Great. Thanks for sharing. Appreciate it.
Thank you. Gerard.
Yes, first of all, Eugene, I want to thank you for sharing today. For those of you who don't know Eugene, he was very humble when he talked about his background. He was in the financial management, like he said, with banks at the C-suite, but at national and global levels, involved in managing, I don't know, billions, maybe trillions of dollars worth of capital that moves globally. So, and with respect to his integrity, because of issues of integrity, he made great sacrifices. And so, again, it's his story to tell. I'm not going to tell it, but he's got an incredible personal story of great accomplishments and integrity. Eugene, I have a question for you.
Yes.
You talked about your background with regards to finance and accounting. You're rolling out a voting system. Can you talk a little bit about how you learn? And you also said that the system was fully compliant with election law. Can you talk a little bit about how you learned about what those election requirements were, how you integrated those election requirements, and then I know you were involved in the distribution of a study, a year and a half study on remote election methods. I'll drop that study in the chat. It's going to be published probably this next week, but I can drop a copy in the chat.
Yeah.
So just talk about the process by which you learned about and integrated election law requirements into this.
Yes, thank you for the question, Gerard. The answer is very clear. I became a member of Global Blockchain Association, first and foremost. And then the organization put together some experts in the field, both representing proponents and opponents of blockchain use in election.
I just want to clear up. Government Blockchain Association, the Global Blockchain Association, is a different organization.
Oh, I'm so sorry. Government Blockchain Association. My mistake. So GBA has put together a group of experts in the space, which all voiced their own views, their own positions as to what are the critical requirements for any blockchain-based system to be adopted. And there were some very hard criteria that had to be satisfied. And one of them, which is very clear, and it's a constitutional requirement, is anonymity of a voter. That must be assured. So very difficult concept to approach, and that's why it was not possible to address for many, many years, severely limiting our ability to provide convenient mechanisms for voters to vote from wherever they are, overseas on a military base, in the hospital, or just too far away from any polling station to attend in person. And the requirement of permanent separation is challenging. It is challenging even with paper ballots, which a threat actor could affect by performing any number of attacks to try to be able to know how somebody voted and maybe extract some benefit for themselves for it, or attempt to affect the results somehow. So we must ensure that nobody, including people who run elections and systems, we must make sure that they're not able to see and not able to associate any particular voter ID with any particular bulletin. In our case, this is addressed by using the zero knowledge snarks technology, which we prefer to call ROS 16. And it indeed allows you to do that. So anything else is just not applicable. Any system must openly show, and again, specialists may be able to come, should be able to come and verify this, that no person has access to information as to how a particular voter expressed their will. So yes, that is assured in this particular solution. And we believe that it is the only approach, Gerard. Thank you for your question.
And one last thing about that, Eugene will be covering this at the conference that we're doing September 29th and 30th on blockchain and infrastructure. So we've got a whole section on critical infrastructure, including elections infrastructure. So we'll have folks from CISA, the National Security Council, a number of high-level government officials talking about the need for election security and literally how it impacts our democracy.
Yeah, I would add to that, Gerard, also that, and this is very important, that I believe for the first time we will be addressing another critical issue directly tied to the needs of high security and protection, and that is software supply chain security, right? A different issue than voting I'm describing today, but since you mentioned, I think it's incredible what type of solutions blockchain can help provide to address the executive order of our president last year, which essentially instructed all of the government agencies to significantly improve their software supply and security process. And we see no better way to do that than to sign blocks on blockchain. So yeah, in September, those of you who will attend, and I would certainly encourage everyone to attend, there will be some fascinating new technologies highlighted there as well. Thank you.
Thanks, gentlemen. It does not appear that we have any further questions. If you want to continue on, Eugene.
Yes, thank you. Let me see then if I can very briefly talk about another product we developing, and they're called DeAudit, right? Do you see DeAudit on your screen, Joshua?
Yes.
Okay. So again, we have very little time left, so I'll kind of run through this very quickly. But in addition to helping people vote from their phones and other devices, we have been looking at how we can increase trust at polling stations. Now, needless to say that a lot of this is kind of stemming from the accusations and disputes that took place in 2020 election cycle. I know that there were a number of claims that something fraudulent was happening at a number of polling stations. And we thought that maybe we can provide something that will help reduce the likelihoods of any threats becoming effective during the election process by using volunteers at the polling stations, using their devices, using their smartphones to perform certain actions that overall will lead to increase in trust to those results that are reported by LEOs. Again, there's clearly a lack of trust in the process at the moment in the society. A very large number of people are not feeling that their votes were properly represented and counted. So we believe that some kind of elections verification system is needed, and the audit was born in the community to address that. Again, this is a product that was originated and paid for by a wide community of people. To mention the size, today we have 750,000 users of the network, and it's growing via organic growth. We do not advertise. People just come when they learn about this possibility, join the community, and contribute. So what the audit is basically is a universal blockchain-based framework for voting results audit to make elections more democratic and fair. It strives to make the voting more transparent and trustworthy by crowdsourcing the results validation process. The core functionality here, and again, it is decentralized, the audit of protocols from polling stations with the use of observers and volunteers. Today, we already have observers from all interested parties, from media and local representatives present in all polling stations locations. So we can draw upon those people to see if the DeAudit results can be achieved. But today, those observers don't necessarily increase trust in the results, and we believe we can change that. So a suggested solution is the audit technology, which essentially evidences any possible violations and bring them to light. The voting process monitoring is very slightly modified by the audit by having all the protocols from polling stations analyzed, any deviations from standards, from past results, carefully analyzed, recorded, and then uploaded to blockchain. So making this data public immediately after results are received certainly increases transparency and allows for much easier auditing. It is using some of the key features of blockchain technology, distributed ledger. Basically, mutability is key. It makes it essentially impossible to tamper with the records, and the system records all of the happenings in the elections to a chain of blocks, which again, with timestamps, make it not possible to modify in any way. Most of the blockchains today, including Everscale, are proof of stake protocols, which are eco-friendly. They're efficient, and they are very easy to use and also very fast. So we also, through blockchain, allow for full public access to information recorded. So we all know a number of violations that were claimed, additional bulletins, wiping of some portions of votes from the voting rolls. There are obstacles in the voting process for certain groups of voters from time to time, and throwing out undesirable votes, fake ballots, and a variety of other things, all of which the audit helps identify and challenge. So we work on addressing the lack of trust. We are making it impossible for bad actors to have possible steps that they can take. We make it impossible for them. And then if any errors or violations are found, the audit allows us to input the correct data by creating a complete data set with absolute trust. So the audit process requires a number of participants. In the interest of time, I will skip the description of what these guys want to do. Please reach out to me with any questions. What I will mention, though, is that the system is based on rewards and slashing. So essentially, good actors are rewarded for their performance, and bad actors are penalized for bad actions. We believe that economic incentives here are appropriate and will significantly increase trust in the system. Joshua, in the interest of time, I'm going to stop now. There's still a lot to say. Maybe at some other point we can come back and I can highlight some of the other products Everscale is bringing to the world. Thank you.
That's incredible. Thanks, Eugene. I'd like to offer any additional questions for Eugene Morozov from Everscale. Feel free to type in the chat or take yourself off mute and address the group. And thank you again, Eugene, for being here today.
Of course.
Hi, this is Tim Gilday. I apologize, Eugene, if I missed this piece, but from an identity perspective, is it multi-factor authentication? How are the original voters ensuring that their identity is not fraudulent?
Yeah, it's a very, very important question. It is addressed in a number of ways. First and foremost, let's keep in mind that the requirements for voter identification differ from state to state. And for example, if a government ID is required to identify the voter when he or she, for example, picks up the bulletin from an election official, then this can easily be implemented. And in fact, we have a module like that already, which allows you to work off a document. That experience shows that that's not enough. And therefore, we have a number of other solutions to identify the voter which can be utilized. And those are, well, as I said, first is government ID. Second is biometrics. The third one is social media activity. There are solutions that allow you to identify somebody by what they do in the social media. And there are some other ways to identify the person. For example, the financial credit system in this country is using some multiple choice questions that only a particular individual will have the answers to. When you apply for credit, for example, the system asks you where you lived at such and such times, what are the things only you would know, which financial institution you were with 10 years ago, what was your first car make, and many other types, which individually can probably be breached, even biometrics. But if you use a combination of those and then match that with the securely obtained voter eligibility list, then we believe that the level of proof will be even higher than modern transactions with billions of dollars in cross-border trading, for example, right? It will be more reliable, more secure than, for example, Bitcoin itself, right, which no one has been able to breach. So we believe, due to high importance of this issue, a combination of identification mechanisms should be used. And this is what we plan to have. I hope I answered your question. Thank you.
Perfect, thanks.
Hey folks, this is Josh.